Hi everyone. We're looking at identifying discrete and continuous functions. Discrete sometimes is also known as discontinuous because look at this nice little graph here. This is called a discrete function and it has isolated points. The continuous function, well obviously it just continues and you don't have to lift your pencil at all in order to draw it. Alright, let's take a look at why you would have two different types of graphs. So, we have discrete data. If you were working on something that had discrete data, for example, the number of students in the class. Well, let's say as the number of days went on in school, we have 3 students, 4 students, 5 students, and so on. So that would be a discrete data situation because you can only have whole students. You can't put half a student in and have a continuous movement. Also, you have dice here. Here's another example. If you roll a dice, you're either going to get one of these several numbers here. You can't get 2.5, 3.5, and so on. So if you were to, graph this, let's say you roll 3 times, you have 2 3s. So you could only graph it with discrete numbers. You cannot go in between the 2, the 3, the 4, and so on. So you have a jump in your graph, which causes it to be discontinuous or also called discrete. All right. Now, most graphs are going to be continuous because most of the time we're doing measurements when we do these types of things, these experiments and so on. Like a person's height. It can be any value, and it's we can get very specific about being at 2, like I'm 5'3.5", okay? You could have, when you're 2 years old, you could be 32 inches tall and 32 1/4, okay? So it's very continuous. Time in a race, you could even measure it to a fraction of a second. So that is definitely something that you could have a line going through and create a line to show how fast somebody went in a certain amount of time. A dog's weight is continuous, the length of a leaf. Anything you can measure will cause you to have continuous data, and you should be able to get a nice fluid, continuous line. All right, let's take a look. Graph the function y equals 2x minus 1 with the given domain, classify the function as discrete or continuous, then identify the range of the function. If we place 0 in here, we obviously get a -1. If we place a 1 in here, 2 minus 1 is 1, so you get 1. And if you put the 2 in, so on. Here's your point. So the graph consists of individual points, so the function is discrete. The range is simply the numbers that are the outputs, -1, 1, 3, and 5, the y values. Now, if you can have x is greater than or equal to 0, that will cause you to have a continuous function because you can keep moving in little tiny increments and it can cause it to go up. Now what happens is you get the exact same thing as here, but this one is discrete because you're just putting specific domain values in and you get very specific y values out if you have discrete data. If you put continuous data in measurements, you keep going from x greater than 0 and you'll get little tiny numbers if you needed to. And you get y, the range value, is bigger than -1 because everything on the graph is from -1 up. All right, let's take a look at another problem. All right, graph the function y equals 1/2 x plus 1 with x is greater than or equal to 0. Classify this function as discrete or continuous. All right, pause your video and give it a try. Welcome back. Let's take a look. First of all, it has x is greater than or equal to 0. So if we have that type of thing going on, then we know it's going to be continuous. And then we also take a look at what would our range be. Everything on the graph is from 1 and up. See how this line keeps going up, up, up. So y is equal to 1, and it's also bigger than 1, just so you know your range. All right, let's take a look at our next picture. Let's take a look at this. Okay, classify and graph a real-world function. Tell whether the function represented by the table is discrete or continuous. Explain. If continuous, graph the solution and find the value of y when x is 1.5. Okay, duration of a storm, amount of rain. Can you imagine as time goes on, you get more and more water in your yard, right? And you can measure it. It's not going to jump from 0.5 inches to 1 inch. So you would expect this to be a continuous graph. All right, this is the book's definition of y. Although the table shows the amount of rain that has fallen after whole numbers of hours only, it makes sense to talk about amount of rain after any amount of time during a storm. So it's a continuous function. That's their reasoning. Write down sum it up what you want to write, okay? Now, obviously this is continuous, so you could place in your x values and your y values, go over 1, go up a half. You'd have to have a really, look at these numbers, 0, 1, and 2 on your y values so that you can get this graph to look nice. All right, next question. Tell whether the function represented by this table is discrete or continuous. Explain if continuous, graph the function, and find the value of y. Hours hiked, distance. Think about this, pause your video, and decide if this should be a continuous graph or a discrete graph. Welcome back. Obviously, we're looking at measurements here because we're talking about how far someone walked after a certain amount of time. Both of these can be measured in continuous ways, so the graph should be continuous. All right. And now the other thing we need to know, this is what the graph would look like. If you place a 1 in here, you get 2.5 out. So over 1, you go up 2.5. You have 2 hours in, you hike for 5 miles, so 2 hours, 5 miles. Hike for 3 hours, you get 7.5 miles, so 3 hours, 7.5. And you'll notice that you can continue this on because you didn't suddenly go from 2.5 miles to 5 miles. You continued to hike. All right. Thanks for watching, and we'll see you tomorrow.